Good evening, students. This is Deekam Pathak from Freebirds Experiences. I welcome you all to this wonderful series called Fun with NCERT. We'd like to start our session by expressing our gratitude to the Government of Meghalaya and of course Innovation Hub, Shillong Science Centre for making these sessions free for students. The aim of these activity-based workshops are to ignite the love for science and technology in students and to recommend the textbooks as published by the NCERT. Now a little bit about ourselves. Freebirds is a community of experiential travelers, learners and hosts connected by the common purpose of enriching lives through experiences. We bring to you domain experts to make learning fun and interesting. We are partnering with Educult, a student community started with a mission to democratize learning in the Northeast India. And lastly, do keep the links handy for all these sessions and follow Innovation Hub's Facebook page to receive updates about the sessions and schedule. So let me not take much time and hand over the session to Mr. Abhishek. Mr. Abhishek, please continue on with this session. Thank you.
Yes. Good evening, everyone. My name is Abhishek, and today we'll be learning a little bit about a software called GeoGebra, which is actually useful in learning and teaching mathematics. With this software or this tool called GeoGebra, we are going to learn about this following activities from mathematics. Let me just share the screen right now. And today we'll be looking at these activities. We'll try to prove these theorems and these properties using this software called GeoGebra. Let's start with GeoGebra directly. We'll be looking at these activities while we go through the session. Now, let us open this software called GeoGebra. Now, you can see on the screen, if I input geogebra.org, you will see a calculator, right? In this software, you will see a lot of mathematical applications, some tests, and now the problem is, where do we start from? So I always ask the students to first sign in. Now, while you sign in this GeoGebra, you can sign in from your Google account or Facebook account or any other account, but you can use your Google account always, so that you don't have to input the password every time. So yeah, that's one way to do it. Then you can click on the squares out here, and you can see a lot of applications come about. We'll start off with GeoGebra Classic. So in today's session, we'll be looking at most of the apps, precisely 3 apps, the GeoGebra Classic, then the graphing calculator, and then the geometry app. And using each of these apps, we will learn how to go around the theorems in mathematics. Let's start off with GeoGebra Classic. Now, as I click this GeoGebra Classic, you can see a screen, a calculator coming on, and here you can see a 2-dimensional axis, right? And on the left-hand side, you can be inputting your functions. Now, let's say I input this function, x squared. You can directly see a parabola coming in. Now, as you write down functions, the GeoGebra app will automatically capture the function and convert it into the graph. All right. Now this is x squared minus 5x, and let's look at some more things out here. You can see the view button out here. In this view button, you can see the 3D graphics, the spreadsheet, the probability calculator. Let's open up 3D graphics. And over here, what you can see is the parabola on the 2D plane, and over here it's on the 3D now. Let me write down the function xy. Now over here you can see it has been shown as a surface on the 3-dimensional system, right? We can also use the graphing calculator to do similar things. Now, in the graphing calculator, let me write down the function again, x squared, then minus 5x plus 1. it will obviously show a parabola, but over here you can see that all the special points, the y-intercept, the roots or the x-intercepts, and even the coordinates of the vertex are shown. These are the special points, right? Now, over here you can see a list, the table of values. So let's open that up. So let's say we'll start the value at -10 and we'll end the value at 10. And let's take a step of 1. And you will see a list of values or list of points which are on this parabola, right? Now, let me delete this table. And let's write down an equation of a straight line. Let's say y equal to x minus 1. Right? For the line also, you can see the roots and the y-intercept. And also you can see the solutions. Now, if you see the the points of intersection of the line and this parabola, the values after the decimals, it contains more than 10 digits, right? So we can just minimize it by going to the settings menu. We'll click the gear button again. And then from 13, we can, let's say, round it off to 2 decimal places. Okay. Now you can see the intersection points has got 2 decimal places. All right. Now, again, let me clear this up. Let's just note down some points. You can just write the coordinates 3, 4, and then 10, 2, and some more points, 1, 5, and then 2, 9. Now, that should be enough. What you can do is also drag these points around, and you can see accordingly the coordinates are changed over here, right? Now, let's suppose you want a line of best fit, right? So what you can do is click on this tool and just drag it from the top left corner downwards, and you will get a straight line. Over here in this algebra, you can see that the equation of the line of best fit has been shown. Now, I can just go over here and again round off to 2 decimal places, and you can see the equation. This is the slope-intercept form of linear equation. Right? You can also change the color of the line. All right, and if you show, use this tool, and you can also show the value. The value will show the equation of the line of best fit. Now, if it's a point, using the value, you will get the coordinate. If it's a 2D plane, the value will give you the area of the 2D plane and 2D surface. And if it's a 3D figure, you will basically get the volume. Right? Now, I want to show you another app. We are going to work on that app today. It's the geometry app under GeoGebra. Yeah. So here you can see some basic tools are given over here. The points, the segments, the line for 2 points, polygons, and you can see circle with center. And if you click on more, you will get a lot more tools, right? You will get how to draw parallel lines. You will get angle bisector. You can find out the midpoint or perpendicular bisector. All these stuffs are in this basic tools. And of course, the algebra thing out here, you can write down the function directly. Let's start with the point function out here, right? So you can just put down points on the screen. And after using every tool, you have to basically press enter. So now you can see all the points out here. And if you click on the points, you will get their coordinates, right? Then you can also draw lines. So this one, and I want to draw a line between this point E and point A, and just click this tool and press enter. Easy, right? We can also draw polygons. Right, this is a triangle, as you can see, and if I put the value out here, the area of this triangle is 6.9 square unit. Right? You can also draw a circle. Right? Now this circle, let's take its value. So here it will give the equation of this circle. Right? But we won't be dealing with these things today. We will be looking at simple mathematical activities from school standard or school level NCERT textbook. Let me refresh this page again. You can always use the undo button to go back, but I tend to use this refresh button because it clears everything up. Let me draw a polygon. First, we'll draw a triangle on the right. Now, I want to prove the angle sum property, which is the sum of the interior angles of a triangle is equal to 180 degrees. And we've got this triangle, right? Now, once you draw the triangle, you can move these points. And let's say I need to find out the angles for the angle A, B, and C. What we can do out here is go to Tools, click on More, and under this Measure button, I'll click Angle, and just clicking on this triangle will give the measures of each angle, right? 71, 50.9, and 57.4, and you can see out here, as you move the points, the measure of the angle, it changes. Note that the measure given here is in degrees. Right? Now let me just write down the names. The label of this angle is alpha. The angle name over here is beta. And over here the angle is gamma. Right. Now, let me just input out here. What is the sum of alpha plus beta plus gamma? So I can go to this A, B, C, click on this alpha, beta, gamma, and just write down alpha plus beta plus gamma. All right, I made a mistake out here. Plus gamma. And it should be about 180 degrees. But will it remain 180 degrees for all types of triangle? Let's just see. As you can see, I am just changing the point out here and moving the point. The angles are changing, but alpha plus beta plus gamma it still remains as 180 degrees. Okay. So it can be said that the sum of the interior angles of a triangle is equal to 180 degrees. Right? Simple, right? Let me refresh this again. And then let's look at another property. In a triangle, the exterior angle is always equal to the sum of the interior opposite angles. Right? Let me draw a polygon again. Right. And let me draw a line through this point. Right. Let me take a point over here on this line. Now let's figure out what are the angles. It is 50.2, 40. Let me look at the names out here. It is labeled alpha and this is labeled beta. And I need to find out this angle ACD also, which is the exterior angle, right? Now, to find out this angle, what we can do is click on this angle again, click on A, C, and D, and this will give the angle to be 92.3. Right? Let me figure out what is the name. Okay. This delta. Now, what we can do out here, we can find out angle alpha plus angle beta. Let's see what their sum is. So this alpha plus beta theta is approximately 92.3, which you can see is the measure of this exterior angle. And if I move this, I can change the shape of the triangle. You can see the angle between ACD, which is the exterior angle, it is always equal to the sum of two interior opposite angles. Right? Pretty cool stuff, right? So just like that, we proved two theorems. Let's look at some more theorems now. The next one we are going to look at is the angle subtended by an arc of a circle at its center is twice the angle it subtends anywhere on the circle circumference. All right. Now, what we are going to draw is a circle. Let me just put a refresh on it now. We'll take a circle. Okay. Now, let me take another point on the circle. Let me take it over here and one point over here. Now, let's join this arcs. And we'll join this CA and AB. Right? Now, let me check the angle out here. Angle CDB, it is 42.7. And angle CAB is 85.3. Right? Let me check what is the name of this angle given. It is again alpha, and this 85.3, it is labeled beta. Now we have to check that what is the value of 2 times alpha. So let's just multiply 2 with alpha. As you can see out here, 2 times alpha is equal to 85.3. Right? And it is equal to the angle which is subtended by this arc CB at the center. Now let me move this B out here. This B point. You can see, even though the angle changes, the property which states that this alpha would be beta upon 2, it still remains, right? It still holds true. You can change over here also. But it's clear to see, right? Now, let me draw a line which passes through B and A. Right? So, if I take the point out here, it is basically the diameter. Right? B can be considered as the diameter of the circle. As I move this point C towards E, you can see the angle in this semicircle almost turns to 90 degrees. Right? Now this is our third proof, which is the angle in a semicircle is always a right angle. Right? So you can change the shape of this. And just again bring this over to the diameter. You will see the angle approaches 90 degrees over and over. Right? Now let's look at some more theorem. Angles in the same segment of a circle are equal, or angles subtended by the same arc at the circumference are equal. Let's go back to this geometry. Let me clear this up again. Let's draw a circle out here. Let me move this B over here. And let's draw some more points on the circle. So this is a point C out here, a point D, and a point E. Let me join the segment CD and BD. and CE and DE. Let's check the angles. Let's check the angle CDB. It is equal to 38.7, and CEB should also be equal to 38.7. There, right? Now I can move this arc out here, and you can see the angles are equal. This angle D and angle E are always equal, right? So this proves our, you can see out here, this angle also it's 35.2 overall, like throughout the whole circumference, and this angle will also be 35.2 over this whole circumference, right? Now this is a proof for our fifth theorem. The angles in the same segment of a circle are equal, or this angle subtended by the same arc at the circumference, right? Then let us look at this theorem. The opposite angles in a cyclic quadrilateral are supplementary. All right. Now let's go back here. Let's draw a quadrilateral inside this. Let me delete this point, this line, this angle. Okay. And then just join these 4 points using the polygon. So C, B, E, D, C. Now, starting from a point and going back to the same point, we'll complete the polygon. Now, let's figure out the angles. All right. These are the angles out here. This is 96.4, 94, 86, and 83 out here. Then, let's do another thing. We'll label it. So this is delta. This one is gamma. This is alpha, and this is beta. So let us figure out what is the sum of alpha plus gamma, or the sum of the opposite angles. So let's just go to this board again. And so we'll see that alpha plus gamma will be equal to 180. Similarly, delta plus beta. Let's figure out delta plus beta. It should also be equal to 180 degrees. So what we have achieved out here is you can move around this point, all right? And you will see the sum of the opposite angles is always equal to 180 degrees. Right? So this is a simple proof where you can see that this actually works. Right? Then let us look at the Pythagoras theorem. Right? Now for this Pythagoras theorem, we'll be needing a right triangle. Let's draw a right triangle. Let me take 4 to 0 and again to 4. So this is definitely a right triangle. Let's see if we can prove it. We check the angle, it comes out. This is the right angle, 90 degrees. Right? Oh, of course, it's an isosceles right triangle out here. So we can change this C out here. We can move around with A and C, and you can see different types of right angle triangles. Now let's check what is AC square. Okay, now Pythagoras theorem states that in a right angle triangle, the square of the side opposite this right angle is equal to the sum of the squares of the other two sides. Right? Now for this, the side opposite the right angle, it's called the hypotenuse. Let's take the square of that. So AC square, it is basically 60.6. Okay. Let me just show the length of this line. So length is 7.8. Let's figure out the length for this one. It is 6.1, and for this one it is 4.8. As you move the point, you can see the length, the value of the length is changing. Right? Now let's figure out what is AB square plus BC square. AB square plus BC square. It's clear off, right? Because Pythagoras theorem works that this two has to be equal. But is this equal for every right triangle? We can just move around this point. You can see AB square plus BC square is always equal to AC square. Right? Pretty cool. Now, let's look at another theorem. Okay, now let's look at parallel lines. We have talked about this polygons and triangles and much. Let's look at some parallel lines. Let me again erase all of this stuff up. Now, first, let's look at a segment. Let's draw a segment. Let's say AB. Now, I want a line which is parallel to this. Okay, so this is a line which is parallel to AB. Let me take a point on this. All right, and let me also draw a line passing through this. Let me take 2 points over here, E and F, and let's take a line which passes through E and F. Right? We'll take 2 more points out here, G and H. Now let's look at the angles out here, GEB. GEB, it is equal to 30.5 approximately. Let us look at the angle EFD. Let's look at angle HFC. Let's look at angle, this angle also. All right. Now let's look at the measure. Look at the measure of each angle. All of them are 80.5 degrees. It was not 30.5, it's 80.5. My bad. Now you can see if I change this point, if I move around this point, angles all remain the same every time. I can change around this traversal again. As you can see, the angles are all staying the same. Now over here, this the angles on both sides of E are known as vertically opposite angles. All right. And then this angle 89. Let me just name it out here. This is delta, and over here this is beta. Now delta and beta form a pair of alternate interior angles. Right? So if you've got 2 parallel lines and traversal passes through it, the vertically opposite angles and the alternate interior angles are equal. Now let me also look at another theorem. Let's figure out the angle between EFC. Angle EFMC. And this is equal to 90.2. Let me check out its name. All right, it is epsilon. I hope you can see it. Now, if I add up this delta and epsilon, what will we get? Delta plus epsilon. It is equal to 180 degrees. I can move around this point. You will see that delta plus epsilon is always equal to 180. Right? So the interior angles on same side of the traversal, they form a pair of supplementary angles. Right? This is another theorem which is in this NCERT. You can see all the angles from this parallel lines, even if they are changing, they are all retaining their properties. Right? the alternate angles are equal, the alternate opposite angles, then the vertically opposite angles, and then the interior angles, they form a pair of supplementary angles, right? Let us look at more activities. Now this is related to the basic proportionality theorem. Now, again, let me clear this up. Until then, let's read this basic proportionality theorem. If a line is drawn parallel to one side of a triangle intersecting the other two sides in distinct points, then the other two sides are divided in the same ratio. All right, let's look at it. Let's take a triangle ABC. Now let's draw a line which is parallel to BC. Parallel line. And let's draw it over here. The parallel line passes to this point D. Let me take another point, E. Right? Now, let us find out the ratio of AD upon DB. AD upon DB. AD upon DB is shown to be equal to 1. Right? Let's figure out what is AE upon EC. Now we can change this thing over and over again. You can see we can move this point B, and you will see that the ratio of this two sides, AD upon DB and AE upon EC, it remains the same every time. Right? So this basically proves the basic proportionality theorem. It is also known as Thales theorem. Right? Now, we have also got a midpoint theorem. Right? Now, if AD upon DB is equal to 1, then D is, of course, the midpoint of AB, and E would be the midpoint of AC. Now, in such case, you will see, let's check the distance of DE. The distance of DE is 4. And what is BC now? The distance of BC is 8. So, midpoint theorem states that if D and E are the midpoints of AB and AC respectively, then if I join D and E, DE would be parallel to BC. Okay, that's for sure. Also, DE would be half of BC. Right? It can be seen over here. BC is 8 and DE is equal to 4. Now let's see if it is true for other cases. Right? You can see 5.7, 11.3. So we can also prove the midpoint theorem using GeoGebra. Then let us look at another one. The tangent at any point of a circle is perpendicular to the radius to the point of contact. Okay. Now let's go back to the circles now. Delete all of this. We draw a circle. Now, let's draw a tangent through point B. Let me just drag it. Let me drag this point B out here, and through this point, we'll try to draw a tangent. Now, the tangent function should be over here. Yes. Select point or line, and select this point, and then the circle will give the tangent. Now, if I join AB, and let me take a point out here on this tangent, let's say this is C. This ABC should be equal to 90 degrees. Let's figure it out. But first, we need to join A and B so that it's the radius. And if I check this angle out here, comes out to be 90 degree. Right? So I can move around the circle, I can move the point of contact, and this angle is always equal to 90 degree. Right? Next, let us look at another property. Let me draw a chord. We'll take two segments. And another point out here. And let's check what is angle AFE. Let's try to make it equal to 90 degree. Okay, this is almost 90 degree, right? So I can move out, right? Almost there. 89.8, 90 it will do. Now, if I check the distance of DF and FE, it will almost be equal. And let's check out DF, its distance is 4.7, while FE would have almost a distance of 4.7, right? So the perpendicular from the center to the chord, it also bisects the chord. Right? Now let's look at some more theorems related to circles. Let me draw one more circle. And let's take this point AB, CB. Now let's say I need to find out this length of CB. Okay. Now let me join this segment CA and AB, and let's see what is the distance of AB. So we have got the radius of this circle to be 5.9. Now I need the area of this ACB. Okay. And this can of course be found out using a polygon. If I just draw ACB, you will get this thing, right? This triangle, but I need this shape also. I should include this over here. So what we can do is use the formula to find out the arc, the area of this sector, and also this arc length. Now, here let's look at what is the angle of CAB. CA and B, it is equal to 74.4. Is the available to you? Yeah, 74.4. Now, let's check the formula for r theta. Now, for when the degree measure is given, then the arc length is given by theta upon 360 multiplied by the circumference of the circle. Let's figure it out. Theta, here theta is 74.4. And here it is labeled actually alpha. So let me just write down alpha divided by 360 multiplied by 2 times pi. Let us figure out pi out here. Pi times AC. Okay, that's my bad. This should come at the top. Right, so it approximately gives the area to be 7.7 units. All right. So as you can change over here, you will find different areas for this segment BC, and you can also find out the area of this ACB. Right. So what we did today out here is look at the various features of this GeoGebra geometry app, right, and figure out the activities. We've tried to prove these activities through the GeoGebra app. Now, what you can do with this GeoGebra app, let me just explain. Going to geogebra.org, you will see that there are many mathematical apps, but there are also some resources out here. All right. And there are some free math curriculum, elementary school math, middle school math, and then you can use these resources to learn about various types of theorems. Let me just show you one of the resources. So this is one of the resource which I will be sharing with you, and this is all free, by the way. All right. I can look at this trigonometry. All right. Go to GeoGebra and click over here. You will see a lot of theorems and proofs out here, which you can just play around with. All right. What is in this right triangle? What is the length of the adjacent angle B? All right. So angle B adjacent should be 7. Right. This is 6 now. Oh, see, it's so easy. Now these are very easy problems, of course, but you will find complicated problems as you go on and on inside this GeoGebra. You can do problems related to statistics. You can do problems related to probability. You can do problems related to linear equations, quadratic equations, higher degree polynomials. You can just find out the solutions if there's an intersection between a line segment and a parabola, and list all the special points, right? So yeah, this GeoGebra is a very powerful app, and today we look at trigonometry, more on geometry. In the next class, what we're going to do is figure out some more algebraic identities and try to prove them in this 2D plane, right? So I hope today's session was helpful to you. I'll be sharing some theorems with you, some mathematical theorems from class 7 to class 10. Now, what I'd like you to do is use GeoGebra and try to prove these theorems. All right. You can go and play around with this GeoGebra app. You can just start off with geometry app again. All right. And I would like you to, go through this point, all of the tools given in this menu, right? And it would be very helpful for you in terms of understanding mathematical concepts that I can be very, definite of. It would be very useful to you. So yeah, that's it from today's session. We'll be looking at more GeoGebra apps in the next session. Thank you.
Thank you, Mr. Abhishek, for the wonderful session.
Yeah.
Personally had a great time, and hopefully the students watching this at home will also do. For the closure, do you have Mr. Benjob is here with us? So, Mr. Benjob, do you have something to deliver for the closure?
Yeah, hello. Can you hear me?
Yes, sir.
Yes, Benjob. Yeah.
Hello. Hello.
Yeah, we can hear you.
Yeah.
Okay. So hello, Mr. Abhishek. So nice to see you again.
How are you, Benjob?
Yeah, I'm doing good, man. So it was a really wonderful session, and I didn't expect that all the concepts and the theorems and the proofs would be given through a very diagrammatic approach. So I suppose everybody watching, if not through this session, through the recorded session as well, I'm very sure. And anyone else who is watching through the recorded session, you to also contact us in case you have any doubts, and we'll get right back to you. And regarding the different problems or want to go check out, please go visit the website. There has has highlighted the entire session. So again, I do hope that tomorrow everybody will again take notes of what was being spoken of today. So apart from that, thank you again so much, Abhishek sir, for sharing your expertise with us.
Welcome.
Yeah, I mean, all your sessions are actually very, very much fun. So even there's no way I could have missed it. Also,
This is a new app actually. Like this is an old app, but people don't use this much. Yeah. So if I think that if teachers and students can learn this wonderful app, it would be beneficial to both of them. Both the in learning also and teaching also. So that's why I just
okay, I
wanted to
do.
share. Yeah.
I do realize one thing. I think this will, regarding from the concept point of view, I'm very sure that the students who will be accessing this will gain a lot of benefit. But at the same time, I think it will also benefit the teachers or the teaching staff, whoever is
Yes.
watching. So if there are any teachers out there who would want to know more about this, please feel free to contact Innovation Hub Shillong Science Center, and also please feel free to contact Birds, right?
Yes.
So maybe in if not this month, maybe in the coming months, we can hold a workshop for teachers as well. So I think if that is if Abhishek sir is willing to avail his precious time, because as we
Yes.
know, Abhishek sir is also like he has a very busy schedule. He's a well-known faculty member of math in Guwahati. So thank you again, sir, for availing your precious time, and
Welcome.
to
Thank you
everybody
so
watching,
much.
thank you again so much. Thank you, Freebirds, for hosting this, and I'm pretty sure about the next session will be even more fun and interesting to learn. Okay.
Thank you so much. Thank you so much, all of you. Thank you. Bye bye. We all had a great time.
Okay.
Thank you so much. Bye bye.
Bye bye.
Yeah. Okay. Bye bye, everyone.